All right. Welcome to the first podcast. This lesson is going to be all about energy resources. And I want you, starting off, remember this is on page 13 in your notebook. I want you to start off by setting up your paper as I've shown here. You can do your paper sort of the long ways or straight up and down. It doesn't really matter. And remember to leave room for a summary at the bottom of your page. But you need to make 3 columns. One entitled Energy Resource, one entitled Source of that Energy, and finally the third column entitled Transformation, so what transformations are going on with that energy resource. Once you get your paper set up, then what you're going to do is fill in each column as I talk about each different type of energy resource. So today we're talking about basically how we take an energy resource and we turn it into electricity that we can use. And what you really need to know is all the different transformations that are taking place to get the electricity at the end. So all the different resources we talk about, no matter what the resource is, power plants operate pretty much in a very similar way. For some of them, it's almost exactly the same. There's only one small difference. But here's overall what's going on within a power plant. In most power plants, we're going to start out with heating up some water. You're going to burn something, or somehow you have to get some hot water, and you're going to generate some steam. This is starting with, of course, chemical energy. That steam is then going to be used to turn something called a turbine, or a turbine, and the steam is forced through this turbine, or this turbine, and it makes it spin. Okay? So we're taking chemical energy, we're converting that into thermal energy in the form of the steam, and then we're going to use that thermal energy to generate some mechanical energy in the form of turning of this turbine. The turbine itself, as it's turning, will spin something called a generator, which is the thing that's actually going to generate the electricity. From the mechanical energy of the spinning turbine and the spinning generator, then we end up with electrical energy. And the electrical energy, although you can't see it, I cut off the picture accidentally, but what this is saying here on the far right-hand side is that the electricity then goes on out to your home. So this is basically how a power plant works, no matter what type of energy resource you're using. The most common way that we get electricity, or the most common resource that we use to get electricity, is something that we call fossil fuels. Fossil fuels are called fossil fuels because they take millions of years to form, and they form similar to the way that fossils form. The problem with fossil fuels, well, there are many. The first is that they take so long to form that we consider them non-renewable. They're going to take so long to renew, in other words, so long to get more of them. As we use them up, as we burn them to make our electricity, we are not regenerating them fast enough. So basically, one day they will run out. Now, there's some question about exactly how long that will be and how long it will take to use that all up. But for the most part, they will run out at some point. Now, there are other problems associated with fossil fuels. Fossil fuels also generate some air pollution. You can see that here in this billowing smoke coming out. They generate a lot of air pollution. They lead to the acid rain. Some of them produce these things called sulfur compounds, like sulfur dioxide. And in the air, they combine with water to form sulfuric acid. Now, acid rain is only slightly acidic. We talked about acids earlier in the year. And it's only slightly acidic, but it's enough to kill the bacteria in the soil. And when the bacteria in the soil die, the plants can't grow. So what you see as a result sometimes of burning of these fossil fuels is whole forests dying out. This isn't so much a problem in Florida, but in the Northeast especially. The other problem associated with fossil fuels, of course, is the problem of global warming, potentially global warming and the greenhouse effect, because they do produce large amounts of carbon dioxide. I did think it was important to also just go over briefly how it is that the fossil fuels form. On the left-hand side, you have natural gas, which is one form of fossil fuel, and also oil, which is another form. And both of those form in oceans. You can see here approximately 300 to 400 million years ago, areas that were covered by ocean water. Tiny little sea plants and animals die. They fall to the bottom of the sea, and over time they get covered over by additional layers of silt and sand. Time goes by, and you can see here layers of sand and silt covering over these organisms, and they continue to just be pressed down by those layers of sand. Over millions of years, eventually they're buried deeper and deeper, and in some areas, of course, there's no longer ocean there, but the ocean has been covered over by land. What we can do is, of course, drill down there and get that oil from way, way down underneath, or the natural gas. And that's where we get oil and natural gas. On the right-hand side over here, you see an explanation of how coal forms. Coal forms slightly different, but coal is also a fossil fuel and a non-renewable resource. Coal formed on land in swampy areas, and again, about 300 million years ago. This is before the dinosaurs. There were giant plants, giant ferns and things that died in swampy areas. And the process is similar. You have dirt, sand covering over the dead plants, and then over millions of years they get buried, and in some cases that area is no longer a swamp, and then we can go in and we can dig up that coal and use it as a resource. So you can see here that for the most part, natural gas and oil forms in the ocean through the remains of animals, and coal forms on land in swampy areas, and it's the remains of plants. At this point, if you haven't written anything down yet, you might want to fill in on your chart where we get oil, where we get natural gas, where we get coal, and that first diagram that I showed you of the power plant works for all three. We start with chemical energy. It's converted to thermal energy. Thermal energy is converted to mechanical energy, spinning the turbine, and then it's converted into electrical energy. Those are your transformations. But of course, we talked already about the problems of fossil fuels. So the rest of what I want to talk about are some alternative energy resources that are renewable, those that we can continue to get more and more of, and they're not going to run out. The first one that I wanted to talk about is biomass. Remember, bio means life. Mass is a bunch of stuff. Okay, so this is getting fuel from living organisms. The process is going to be similar, but the difference is that, of course, we can keep growing these plants that we're using as fuel. You see a picture there of corn. Corn is typically used when we're talking about biomass, but there are some others. Sugarcane, I think they use, things like that. Biomass uses a similar process to burning fossil fuels for energy, but in this case, we're growing new plants to burn. Once again, you're going to have a fuel. In this case, the chemical energy comes from green plants. Unlike fossil fuels, we're using plants that we grow. From there, we burn them, we create the steam, convert that to thermal energy, and the steam is going to be used to spin a turbine and eventually spin a generator. So that's converting that to mechanical energy, and eventually, through a transformer, that electricity will be sent out to homes, converting that to electrical energy. So those are your transformations, in this case using green plants instead of fossil fuels to get the energy. The second type of alternative energy resource that I wanted to talk to you about is wind power. With wind power, you're using windmills, giant, huge, tall, 100 feet tall windmills, and using just the power of the wind to generate some electricity. Obviously, this is going to be a clean resource. It's free of charge because it's windy. The wind's just blowing. And it's renewable. It's not going to go away. Although there are times when the wind blows more than other times. In some areas, wind is a really good resource that can be used to generate electricity. What's nice about wind, we bypass the burning of anything. Okay, so we're not burning anything. This step here, The chemical energy step is eliminated, and all you're doing, and actually the thermal energy step too, all you're doing is using the wind to spin the turbine. So the wind itself spins the turbine spins the generator, so you have mechanical energy from the wind that's going to be used to spin a generator, and then the generator generates the electricity and it goes out to the homes. So you see we're skipping 2 steps. One thing that I haven't told you about is energy efficiency, but with every transformation of energy, you're going to convert some of that energy to thermal energy, which we talked about, and so you're losing a lot of that energy along the way for every transformation. If you skip some transformations, then you're going to be even saving more energy because you're not going to be losing that to heat. Next, I wanted to talk to you about nuclear energy. Nuclear energy is a good alternative. You don't have to burn anything once again. In this case, you're still heating up some water, you're creating steam to spin the turbine, but rather than using chemical energy, you're using the energy that comes from a nuclear reaction. So you're splitting that atom and controlling the energy that comes out. Like I said, you split that uranium atom, a bunch of energy comes out. If you can control that, you use that energy to heat up your water. And once again, you're going to spin the turbine. Turbine's going to spin the generator. It's going to generate the electricity and go out to everyone's home. So you still have the same number of steps: nuclear energy to thermal, to mechanical, to electrical. But in this case, the nuclear energy doesn't come from burning anything. It comes from the energy from splitting an atom. Next form of energy is hydroelectric. In hydroelectric energy, what you're using is gravitational potential energy. You're using height, basically, to get some energy. What they do is they go into an area where there's a good source of running water, an area where there's a real sizable river, and they dam part of the river. They build a large dam. Then they control when the water comes down. Rather than letting the water just come down the river, they control it. And they'll back up that water till it's quite high, and then they allow the water to fall down in a specific place, specifically where it will spin a turbine. So now the dropping water, due to gravitational potential energy, the dropping water will spin the turbine. Once again, the mechanical energy spinning the generator, converting that into electrical energy and going out to the homes. So once again, we're saving a couple of steps. We're not using chemical energy or thermal energy in this case, so it's going to be more efficient. However, you can probably imagine some of the problems with hydroelectric. You're damming a river and you're destroying ecosystems in the process, and it's not going to be available everywhere. You're not going to have a good river to use for this just everywhere. So think about that as we learn about the next one. The next renewable resource I wanted to talk to you about is geothermal energy. And this one's quite unique. Once again, we're using thermal energy, and we're going to spin a turbine with it. But this time, you're using water that's already hot. It's steam from the earth itself. So in areas where there is volcanic activity, a lot of times water sources nearby are very hot due to the magma, the underlying magma that's just real close to the surface. Or sometimes the groundwater itself is touching the magma underneath the surface, and it gets superheated. What they can do is tap into that hot water and use it again to spin a turbine. It's going to be renewable because the earth itself is not going to stop being hot in our foreseeable future. But of course, one of the problems with it is that it's not going to be just everywhere. It's only areas where there's volcanic activity going on. But once again, you're going to use that steam from inside the earth to spin a turbine. Okay, you're taking thermal energy and converting that into mechanical energy. And that's going to spin your generator. That's going to generate the electricity. And that's going to be sent out all along the cables to everyone's home. The last energy resource that I wanted to talk about is solar energy. Solar energy, using solar energy for generating electricity uses something called a photovoltaic. Photovoltaics can directly convert the sun's energy into electricity. What's really cool about solar energy is that you're bypassing electrical or chemical energy, you're bypassing thermal energy, you're even bypassing the mechanical energy. You no longer need a turbine, you no longer need a generator, and now all you're doing is taking the radiant energy from the sun and directly converting it into electrical energy. Super efficient, and probably, as you can imagine, always available, never going to run out, at least for another 5 billion years, as long as the sun exists and the earth exists as well. But of course, in some areas it may not be that useful because the sun doesn't shine that much. But think about that. So that's all of the alternative sources that I wanted to talk to you about, and also the non-renewables, the fossil fuels. Finally, what I do really want you to understand is, what are we using in the United States? What are we using in Florida? And are there any changes that possibly may need to be made? I want you to be thinking about these things as we start our project on Wednesday. But as you can see, there's a variety of different energy resources being used in the United States. Probably most commonly is coal, from what I can see. We do use coal in Florida. We also have some nuclear power up in the northern part of the state, and I do believe there's one along the coastline. And then we're also using oil. So as you can see, in Florida, we're not utilizing solar. We're not utilizing wind power or anything like that. And really, overall in this country, we're using primarily, it looks like, coal. And then natural gas out here in the West and in Texas. Okay, that's all I have for you today. Make sure you write down those notes, and I'm going to be looking for those notes on Wednesday in class. Have a good day.
Made with Doodlecast Pro.